Through the lens of computer modeling, a dedicated research team delved into 4 ecosystems facing serious threats. Their goal was to uncover the elements that might lead to tipping points, beyond which a collapse would be unavoidable. In certain systems, they found that combining new extreme events with existing stresses could bring tipping points much closer, by as much as 80%. The authors concluded that a perfect storm of persistent stressors, like unsustainable land use, agricultural expansion, and climate change, combined with disruptive events like floods and wildfires, would work together to jeopardize natural systems rapidly. More than a fifth of ecosystems globally are at risk of collapse, remarked Professor Simon Wilcock, a company leader of the study. Yet, ongoing stresses interact with extreme events, quickening rapid changes that may spiral beyond our control. Once we hit that tipping point, it becomes too late. The team investigated 2 lake ecosystems and 2 forestry cases, including the infamous collapse of the Easter Island civilization. This was widely blamed on overpopulation and unsustainable tree exploitation. They ran over 70,000 simulations for each ecosystem, tweaking variables each time. Astonishingly, up to 15% of roadblocks to stability arose from new stresses or extreme events, even when the main stress was kept stable. Essentially, even sustainable management can't safeguard ecosystems if additional threats, such as climate change, are present. Since 1980, the frequency of extreme climate events has risen, and global warming at even 1.5 degrees Celsius will heighten these occurrences further. Scientists worry about cascading effects, as a failing ecosystem may disrupt its neighboring systems. In the past 2 years, the global community has united in response to climate and ecological crises during the UN Climate Change and Biodiversity Conferences. However, it's crucial to understand that the causes are interconnected, they have already clashed. Inaction could lead to catastrophic outcomes, cautioned Wilcock. Earlier studies suggested that from the latter half of the 21st century, ecological tipping points could incur heavy social and economic costs. Our research implies that these costs may arise sooner than expected, added co-author Professor John Deering. For instance, the UN's International Panel on Climate Change, IPCC, anticipates a tipping point in the Amazon forest before 2100. However, this new study suggests that such a breakdown might occur decades earlier than predicted. The Amazon forest, heavily threatened by deforestation, might also face additional stress from global warming and extreme weather, such as droughts and wildfires. This could diminish its ability to create its own rainfall, making it drier and more susceptible, leading the ecosystem into a detrimental cycle. All 4 ecological systems we studied revealed similar overarching outcomes, mentioned co-author Dr. Gregory Cooper. This has profound implications for how we view future ecological risks. While it's currently impossible to predict the connections between climate-induced tipping points and local human actions, our findings indicate that each can amplify the other. Any added pressures on ecosystems can be devastating and carry serious consequences.